We derived Cauchy's equation by using the divergence theorem. We will derive the same equation by using another two methods which are very familiar to us. One is by considering a small infinitesimal volume of fluid and see the different components of fluid flow, for the velocity field, the tensor, the stress strain tensor, and also the other part, the gravity forces and so on, and see how does it look like, or whether we can arrive at the same result or not. And then we will also derive the same equation by considering simply the Newton's law, F is equal to ma. So for this purpose, we consider an infinitesimal control volume on which we apply conservation of linear momentum, the linear momentum where the forces are balanced by the velocity field or the momentum field, in which we also see how the density behaves, how the forces on density acts, and what is the result, what is the outcome of this. And when the fluid is viscous, then at that time it introduces stresses and strains in fluid motion. So we shall be considering the variation in rho, the variation in u, v, and w, and the variation in stresses and strain. And for simplicity, we consider only the x component of our main equation. And when we consider the x component, we can, by symmetry, we can easily see that similar components or similar equations will be contributing to that momentum equation, in which the forces are balanced by the momentums. So we shall consider them shortly.